Hello and welcome to all participants from around the world. My name is Arya Peruma and welcome to today's webinar, which is on the topic of simplifying algebraic expressions using the properties of exponents. And today we'll be learning about the 5 main rules or properties of exponents. You will see examples of these properties and how they can all be integrated in one huge problem, which we'll be looking at the end of this webinar. So with that, let's get started with our very first problem and concepts, which we're going to be learning. So before we dive into the rules of exponents, we first need to take a look at a very simple concept, which is very important for these kinds of problems. That's basically identifying the parts of an exponent. So essentially, this is a very important concept to know, as these terminologies, which I will be mentioning soon, will be brought up frequently throughout this webinar, as well as many other math concepts you will see in the future. So for example, if you had a to the power of n, this a over here is what we call the base, this huge number over here. And this tiny number, which is kind of the power, is the power. So this is the base, this is the power. So similarly, if you had, for example, 7 to the power of 2, this 7 over here is the base, and this tiny 2 over here is identified as the power of the base, which is 2 in this case. So now that we have these terminologies established, keep in mind these are very important to know as they'll be frequently brought up in this webinar. We can now start learning the rules of exponents. So the very first rule of exponents we're going to be learning today is called the product rule of exponents. So essentially, the product rule of exponents basically states that a to the power of m times a to the power of n is equal to a to the power of m plus n. And essentially all this product rule of exponents states is that when the bases are the same and the two exponent values are multiplied and they have the same base, in order to evaluate for this expression, the exponents actually can be added. So you would keep the base the same and you would add the exponents. So for instance, over here you have a to the power of m times a to the power of n, and as you can see, both of these both have the common base of a. So we just write that base as is. In order to evaluate for this, we add the exponents up. So m plus n, that's the exponent of this, and exponent of this is n, so you would add them up. So I'll be going over a few practice problems using the product rule of exponents with you to get you accustomed and familiarized with these kinds of problems. So the first example we'll be taking a look at is a to the power of 3 times a to the power of 2. So essentially, as you can see, the product rule of exponents is easily applicable to this problem. As you can see, the bases are the same, they both have exponents, and they are multiplied. So therefore, using the product rule of exponents, we keep the base same, the base is common, the base is a, and take a look at the exponents. So the exponent of this is 3, and the exponent of this is 2. So in order to evaluate for this, what you need to do is you need to add the exponents as per the product rule of exponents. And when adding the exponents, we have now a in the base, and for the exponent, we have 3 plus 2. 3 plus 2 is 5, so therefore our final answer for this question is a to the power of 5. So now let's try another problem using the product rule of exponents. So our next problem will be 3 to the power of 2 times 3 to the power of 6 times 3. So essentially, as you can see, in order to use the product rule of exponents and apply it, we have to make sure that all our values here have the same base. And yes, they do all have the same base. They all have a common base of 3. So using the product rule of exponents, we keep the base as is. The base is 3. But in order to evaluate, we know that using the product rule of exponents, we need to add the exponents up. So adding the exponents up, we have 2 as the exponent for this, we have 6 as the exponent for this, and we have 1 as the exponent for this. So we have to add the exponents up. So I'm going to be adding them up. So this has exponent 2, this has exponent 6, and this has exponent of 1. Because remember, when there's just a numerical value here with no actual exponent given here, you can just assume, and it is already understood, that the exponent of that is 1. So now, evaluating this even further, we know that we write the base as is, and we add the exponents. So adding 2 plus 6 plus 1, that gives us 9. So therefore, the answer to this is 3 to the power of 9. And if the question permits, you can simplify this further by actually finding the exact value of 3 to the power of 9. But for this specific problem, we can write this answer as is. So now let's take a look at one final problem for the product rule of exponents, which we'll be doing today. And this is 2x to the power of 3, y to the power of 5, and z times 5x y to the power of 2, z to the power of 3. So as you can see, this problem may appear a bit daunting, and it may seem like it is a more complex problem than the previous two which we had done, but this actually is very simple because it does apply the product rule of exponents, which we've learned over here. So as you can see, rather than there being just one type of base, like question 1 and 2, there is actually multiple bases. So there is just numerical values of 2 and 5. There's x variables, y variables, and z variables. So we kind of need to figure out a way to apply the product rule of exponents with a question like this, which has multiple bases, which you can apply the product rule of exponents for. So in order to do this, the easiest method would be to kind of rearrange all the values. So what I mean by this is putting the numerical values with the numerical values, the bases in terms of x with each other, the bases in terms of y with each other, and the bases in terms of z with each other. And this will just easily help you visualize what you need to do in order to apply the product rule of exponents. So what I'm going to be doing now is I'm going to be rearranging this. So I can see we have all of this multiplied. So this is all multiplied with each other. So we have 2 times 5. We can rewrite it as 2 times 5 as everything's multiplied anyways. So now taking a look at variables that have x, we have x to the power of 3 and just x over here. We have y to the power of 5 and y to the power of 2. We have z and z to the power of 3. So as you can see, we have all of this. And now what we have to do is we have to see if we can apply the product rule of exponents. So as the product rule of exponents does state, whenever you have two values that have the same base and they have exponents and they're multiplied with each other, we can just add the exponents to create our answer. So exactly what we're going to be doing here. We are going to take a look at this, and we know that 2 times 5 is just simply 10, so we're just going to write that. And now, as you can see, we have x to the power of 3 times x. And remember, we just got this by just rearranging this multiplication of polynomials here. So by rearranging that, what we did is we've done x to the power of 3 times x, and as the product rule of exponents states, same base. Now they're multiplied, and we can add the exponents. So therefore, we can say x to the power of 3 plus 1, because remember, we're just adding those exponents up. For y variables, variable base y, we have exponent 5 and exponent 2. So since they're multiplied, have the same base, we are going to just add the exponents up. And finally, we have z here. So base z, one has exponent 1 and another one has exponent 3. So using the product rule of exponents, we know we have to add the exponents up So 1 plus 3. In the next line, what we need to do is now simplify this further. So we know this has 10. We know this is x, but we know it's raised to the power of 3 plus 1. We know 3 plus 1 is 4, so we can write that. Next, we have that multiplied by base y to the power of 5 plus 2. 5 plus 2 is 7, so we're going to write that. And finally, we have z here, base z, and that is raised to the power of 1 plus 3. 1 plus 3 is 4, so we're just going to write that as power of 4. And therefore, this is our final answer for this question. And as you can see, it is not as complex as it seems once you get accustomed to this law and you start applying it to these types of problems. So great, now that we've learned our very first law, let's go on to our second one, which is the quotient rule of exponents. So essentially, the quotient rule of exponents states that a to the power of m divided by a to the power of n is equal to a to the power of m minus n. And essentially, all this states is when you have, once again, keeping the idea in mind of same bases, when you have a value which has the same base divided by another value which has the same base, in order to evaluate these kinds of problems, what you would do is keep the base as is, and you would subtract the exponents. That's exactly what's happening here. As you can see, we've kept base a as base a, and we're subtracting the exponents from each other. So the numerator had base a with the exponent of m, the power of m here, and the denominator had base a with the power of n here. So we just subtracted those exponents. So now I'm going to be going over a few practice problems which we can apply the quotient rule of exponents for to get you more familiarized with this rule. So the first one is a to the power of 5 divided by a to the power of 2. So as per the quotient rule of exponents, we know that if these have the same bases but different exponents, or could even be the same exponents, just same bases, and they are divided by each other, what we have to do to evaluate is subtract the exponents. So we have just base a here. So I'm just going to simply write this as base a here. And now subtracting the exponents from each other. So we have exponent 5 minus 2. So now evaluating this even further, we have just base a here. And looking at the exponent, we have the exponent of 5 minus 2. And we know 5 minus 2 is 3. So therefore, your final answer would be a to the power of 3. So now let's try another one. So our next question, which we're going to be trying, is 7 to the power of 13 divided by 7 to the power of 5. So as you can see, we essentially will apply the same quotient rule of exponents to this as well. So now we just have to identify if they do have the same bases, and yes, they indeed do have the same bases. So same bases, and they are divided. So what we can do is we know that using the quotient rule of exponents, keep the bases same, but we can subtract the exponents. So we have 13 minus 5 for the power. And now simplifying this even further, we have 7 to the power of 13 minus 5. 13 minus 5 we know is 8. So therefore this is our answer. And once again, just as our previously done problems in the product rule of exponents law, which I've taught previously in this webinar, as you can see, what happens is that you can actually evaluate for this further if the question does permit you to do so. But for now, this is an adequate answer. So now our final question, which we'll be doing, applying the quotient rule of exponents, would be 5a to the power of 3, b to the power of 5, c to the power of 2, divided by 2a b to the power of 3 times c. So essentially, exactly how we did previously, there was multiple variables and bases here. So rather than there just being one kind of base like questions 1 and 2, we have multiple variables, so A, B, C variables, and we also have numerical values as well. And we can definitely apply the quotient rule of exponents to this problem. We just need to split it up as we did previously. So looking at this, we know that 5 divided by 2, since they're both numerical values, we know that it can just divide. So we have 5 over 2, so we're going to be writing 5 over 2. Now, we have to pay close attention to these variables here. So we have A, B, and C variables. So as per the quotient rule of exponents, we know that when there is the same base and those are divided, we can actually subtract the exponents to evaluate for our answer. So we have a to the power of 3 here in the numerator and a here in the denominator. So taking a look at everything in terms of base A, what we can do is we just write that base A as is, and we would need to subtract the exponents. So we have a 3 here in the numerator, so we're going to be subtracting 3. And now here we just have an a, but we know that when there's just a value by itself and no exponent written, it is understood that it has an exponent of 1. So we subtract 3, which is the exponent of a here, minus 1, which is the exponent of a here. And we're just going to go ahead and do the exact same thing for bases of b and c. So we have base b raised to the power of 5 minus 3, because 5 is the exponent here, 3 is the exponent here. So as per the quotient rule of exponents, we do need to subtract the exponents and just keep the base the same because both do have base b. An exact same thing with c. So we have c to the power of 2 minus 1. Exactly for the same reasons we did it for a and b, just we saw that c and c both are in the same base. So using the quotient rule of exponents, we subtract the exponents in order to evaluate. So now simplifying even further, we have 5 over 2 times a to the power of 3 minus 1. Well, we know 3 minus 1 is 2, so we can write that as is. And we have b, that's multiplied by base b, to the power of 5 minus 3. 5 minus 3 is 2, so that is to the power of 2. Now we have c to the power of 2 minus 1. 2 minus 1 is 1, but since just a value without an exponent written is already understood that the exponent is 1, I'm just going to write c as is. So therefore, here we have our answer for this specific question. And using the quotient rule of exponents, we were able to break this problem up and break it up into individual bases and pair the bases up so we could easily solve for this problem. So now moving on to our third rule, which we are going to be learning today. This is the power of a power rule of exponents. So it's called the power of a power rule of exponents. So the power of a power rule of exponents basically states that when a to the power of m is raised to the power of n, that is equal to a to the power of m times n. And I will just basically tell you what this means and what this essentially states. So basically, this power of a power rule of exponents basically means that when there is some exponent, so when there is some base raised to a power, and that whole expression is raised to another power, what happens is you keep the base as is, but you would multiply the two exponents. So for example, if you had a raised to the power of m, and that whole expression is once again raised to the power of n, what you would do to evaluate is keep base a as is and multiply m and n. So in order to further clarify this concept, I'm just going to be going over a practice problem using the power of a power rule of exponents with you. So we have this question, which is a to the power of 2, and that's all raised to the power of 3. So essentially, as per the power of a power rule of exponents, we know that when there is a base raised to a power and that is raised to another power, what we do is we write the base as is, the base is a, but we do multiply the exponents. So we do multiply the exponent a is raised to, But we also multiply with the exponent that this whole expression a to the power of 2 is raised to. So we multiply 2 with 3, and if we further simplify this, see that we have a in the base, and in the power we have 2 times 3. And 2 times 3 is 6, so we can go ahead and state that this problem's answer is a to the power of 6. And it is really quite simple once you get accustomed to these rules of exponents. And as you can see, just using this, it's very simple to easily solve or simplify for these kinds of problems. So now moving on to our fourth law or rule of exponents, which we are going to learn today. It is called the power of a product rule of exponents. So once again, it's called the power of a product rule of exponents. So the power of a product rule of exponents. So the power of a product rule of exponents essentially states that when there is a times b in brackets raised to one power, central power, that is equal to a to the power of m times b to the power of m. So I'm just going to go ahead and explain what this rule of exponent really means. So basically, this means that when there are certain values all multiplied with each other inside a set of brackets, and that is all raised to one power, all in brackets, and that's all raised to one central power, what happens is that is basically equal to every single value inside those brackets is going to be raised to that power. So as you can see over here, we have a times b all raised to m. So what happens is a is raised to the power of m, but so is b. B is also raised to the power of m. And that would apply for however many values there are inside the brackets. So keep in mind, this rule, this power of a product rule of exponents, only occurs and only works when terms or numbers are multiplied within brackets. So what I mean by this is this rule will only work when there's multiplication between the values. So it has to be a times b raised to the power of m. However, if you had a plus b raised to the power of m, this is not equal to that. This and this are two completely different things. So do not get confused with this and that. Because as you can see, there is multiplication here between the terms, and this is addition between the values. So essentially, this power of a product rule of exponents only works when there is multiplication within these brackets. And keep that in mind. So now I'm going to be demonstrating a few problems using the power of a product rule of exponents with you, so you can further understand and this rule can further be clarified. So our first problem using this rule would be ab to the power of 3. So now this is essentially very simple. Using the power of a product rule of exponents, we can easily simplify this down. So we have ab to the power of 3, and as I previously mentioned, as per the power of a product rule of exponents, when there is multiplication between values and it is all raised to one central power, you apply that power to every single value within those brackets. So here we have a and b. So what we need to do is we need to take this power 3 and apply it to a. So we have to do a to the power 3. But also this value of b here, which is multiplied with a, and that's why we can use the power of a product rule of exponents. And we need to take that and also raise it to the central power of 3. So basically, we're going to take every value in there and raise it to that power. And that's exactly what we've done here. And therefore, this is our final answer. As you can see, it's very, very simple. Using this rule, it's very simple to identify and solve and figure out for this. And once you kind of get accustomed to this and comfortable with this, you can easily solve bigger problems as well. So now we're going to be doing one more problem using the power of a product rule of exponents and just applying that. And that is x to the power of 3 times y times z to the power of 2, all raised to the power of 4. So now we're just going to go ahead and apply the exact same things. So now, as you can see, instead of there being two kind of separate values here, there are three separate values in terms of x to the power of 3, y, and z to the power of 2. And it's all raised to a central power of 4. So we're just going to go ahead and solve that. So as you can see, what happens is we need to apply this. So we have x to the power of 3 times raised to the power of 4. So as I mentioned previously, what you need to do is you need to take this and apply it to every single value here. Take this power and apply it to every single value. Exactly what we're going to be doing. So we're going to take x to the power of 3, which is our first value, and we're going to raise it to the power of 4, which is essentially what the power of a product rule of exponents states. We take the value and you raise it to that power. So we take x to the power of 3, raise it to the power of 4. We take y and raise it to the power of 4, and that is just y to the power of 4. And now we take z to the power of 2 and raise it to the power of 4. And z to the power of 2 raised to the power of 4 will look like that. So now, as you can see, what we have is we actually have one more step to do before we actually reach our answer. But as you can see here, we've just applied the power of a product rule of exponents. But you can see that there's one more exponent rule which I covered previously, which can be applied for this. As you can see, looking at the format. And just to refresh your memories, if you don't remember already, that is the power of a power rule of exponents, which basically states that a to the power of m raised to the power of n is equal to a to the power of m times n. So as you can see, this power of a power rule of exponents is basically the exact same format as what we've arrived to using the power of a product rule of exponents here. So now we've applied this power of a product rule of exponents, but now we also need to take a look at this and apply it. So as you can see, over here we have x to the power of 3 raised to the power of 4. So as the power of a power rule of exponents does state, what you can do there is you would just keep the base as is, but you would multiply the exponents, which is what we're going to be doing now. So we have just base x, but now since it's like this, we can now apply the power of a power rule of exponents. So 3 times 4, and now taking a look at this, we just have y to the power of 4. And now we once again can apply the power of a power rule of exponents, which is this over here. We can apply those. And what we can do here is say, just write that base z as is. And now we just apply this power of a power rule of exponents rule and multiply the exponents out in 2 times 4. And now we're just going to further simplify. So that's x to the power of 3 times 4. 3 times 4 we know is 12, so to the power of 12. Y to the power of 4, and that's multiplied by z to the power of 2 times 4, and 2 times 4 we know is 8. So therefore, this is our final answer for this problem. And as you could clearly see, these kinds of problems like this, some will require you to apply more than one law or rule of exponents. And there is really easy to have those in your toolbox. You can pick them out for what the problem requires you to do. So this was just kind of a little taste and how you could clearly see that multiple rules, or two rules in this case, were applied for this problem: the power of a product rule of exponents, as well as the power of a power rule of exponents. So there were two rules applied for this, and this was kind of a taste for you guys to see how multiple rules could be applied to one problem. So now let's move on to the final rule which we're going to learn, and that is called the power of a quotient rule of exponents. So writing that out, power of a quotient rule of exponents. So essentially, the power of a quotient rule of exponents basically states that a divided by b to the power of m is equal to a to the power of m divided by b to the power of m. And now I'm just going to explain what this rule of exponents means. This is basically saying that when you have some values divided by each other, so you have a value divided by a value, and that is all raised to one central power. Similarly to the power of a product rule of exponents, how you would apply the exponent to every value, you do the exact same thing. You apply the exponent to every value inside this bracket here. So you apply it to the numerator, the a on the numerator, as well as the b on the denominator. So basically, you would want to apply this exponent to numerator and denominator, and as well as every value. And that's exactly what this states. So now what we're going to do is we're going to be going over a practice problem, which will help us apply the power of a quotient rule of exponents. And this is a divided by b raised to the power of 3. And now we can evaluate for this. So now applying this power of a quotient rule of exponents, what we can do is we know that since there is a in the numerator and b in the denominator, what happens is we can actually raise the numerator a, the value of the numerator, to the central power of 3, and I'm going to be doing just that. So raise it to the power of 3, and that is divided by b, which is raised to the power of 3 as well. So we're just going to take this and apply this power to every single value, both on the numerator and denominator, as per the power of a quotient rule of exponents. So now we've come to the end of learning our laws for today's webinar. And now what I'm actually going to do is I'm going to be giving you guys a problem to try on your own, which applies all 5 exponent rules learned today. So now, as you can see, we have this exponent problem over here. And what this exponent problem actually is it applies all 5 rules which you learned today. So using those 5 rules, you would need to apply them to solve and evaluate and simplify for this specific problem. So now, as you can see, I have done the first step already for you guys. And I've also given you the final answer, so you can go back and check your work when you try this on your own. In addition, I've also provided you guys with the 5 exponent rules, which I have covered today. And essentially, what you need to do is if you want to go back and refer to them, you may do so. Keep in mind, all these rules will be applicable to this problem, and all of these are very important to know and have at the back of your mind when solving these problems. So as you can see, it started off with this really, really huge problem, and it kind of condensed down to this. So just using these exponent rules and properties, you could see the patterns on how this huge problem would actually condense down slowly. So I've done the first problem or first step here, as you can see, the first step of this problem, as you can see here. And I'm just going to quickly go over that step with you guys, and then you can try the rest on your own. So essentially, all I've done is first, an important thing to keep in mind would be something that I'm sure many of you have heard of before, and this is basically the order of operations. So as you guys know, in the order of operations, you always solve for brackets first. And that's essentially the exact same idea for these kinds of problems as well. You want to evaluate within the brackets first and then keep on expanding out and going out greater and then finally condensing it down. So we do want to solve for the brackets first. So as you can see in this problem, what we have is we have a huge bracket here, but we also have a smaller bracket inside this huge bracket. And that's exactly what you need to go for to evaluate first. That's exactly what I have done. So we already know that we do need to start from evaluating this tiny bracket over here. And using the laws of exponents and the rules of exponents, which have been covered, you have to figure out which one is applicable for what you are looking to evaluate for. So in the case of this, I was trying to evaluate for this small bracket inside here. So taking a look at the rules of exponents learned today, you could see that this rule, the power of a product rule of exponents, is applicable. So a times b to the power of m. So that is applicable for this because as you can see, there are multiple values and that is all raised to one central power. That is exactly what I've done here. I have taken all the values and raised them all to the power of 3. So I've taken 2, raised it to the power of 3. I've taken a to the power of 4 and raised it to the power of 3. I've taken b to the power of 2 and raised it to the power of 3 as well. And as you can clearly see, this kind of also features the power of a power rule of exponents as well. This one over here, which states that a to the power of m all to the power of n is equal to a to the power of m times n. Because as you can see, when you raise a to the power of 4 to the power of 3, it comes in this format and you would now need to multiply the exponents together, which is exactly why I have done that for the basis of a and b. So now just essentially using these exponent rules and properties learned, you could just slowly start condensing them down. So now, as you can see in the next step, you can further simplify. So you know 2 to the power of 3 is 8. You know a to the power of 4 times 3, you can evaluate 4 times 3. 4 times 3 is 12. So we know a to the power of 12. And then we have b to the power of 2 times 3. 2 times 3 is 6. So in the next step, we can say that's b to the power of 6 over here. And then you know this is all multiplied with this. So maybe try and check yourself with which rule would apply to now evaluate for the numerator and then eventually the denominator and then eventually the whole thing. Don't forget about the squared over here. And that's essentially how you would do this problem. So now with this, we have come to an end of today's webinar. And I would just like to thank everyone so much for attending today. I hope everyone enjoyed today's webinar and was able to take away something new and useful away from today's session. Just another friendly reminder that this webinar is recorded. So if you wanted to go back and review any of the concepts or materials learned today, or wanted to go back and check something, or you forgot something and you want to review that, this webinar is recorded and will be posted to our website shortly after the session. That is displayed in the screen you're viewing right now. The link to our website is displayed on the screen you're viewing right now, as well as the chat, and is also typed in the chat and is pasted in the chat. And you can find the recorded webinar on there. In addition, if you had any questions about either concepts covered in today's webinar or anything else, please feel free to email me, and that is also in the chat. So also keep in mind that these webinars are free, so if you know anyone who is interested or would benefit from these free sessions, please feel free to let them know so they may register. And in addition, our next webinar will be on adding and multiplying radicals, so please keep a lookout for that. And I'm also going to be doing coding webinars in the coming weeks, so please check our website for updates on that. And with this, I would like to thank all our participants from around the world once again so much for joining us today. I hope you enjoyed and I hope to see you all soon in an upcoming webinar. Thank you and have a nice day.